Hello everyone, I'm Lucas. So welcome back to the second video of Math AAHL, like this year, like 2025, paper 1 time zone 2. So which is like the harder paper in my opinion. So let's see. So now, since I've last video we've gone through session A. Okay, so hopefully I don't have any careless mistakes. Okay, so I think I used around like 30 minutes for session A, but I think it's actually pretty hard already. Generally, because like compared to last previous AA, this paper is actually pretty hard. So let's try to finish paper like session B in under an hour, under 30 minutes. Okay, so the time starts now. So function f is defined by quadratic. Write f in this form. So first of all, this is a factorized form, right? So we need to write as a vertex form. So what we can do is we can try to sketch out if we wish to. So 5x plus 1, x minus x plus 3. So minus 1 minus 3 is the root. So it looks something like this. Okay, so the vertex will be somewhere here, which is the midpoint of the roots in here, which is I think -2. Okay, and then we can find the coordinates by plugging -2 back into the equation here. So put -2, so f of -2, that's like 5, and then -2 plus 1, and then -2 plus 3. So 5, -1, and then 1, right? So this is the same as -5. So once we got that, so -5, I think the question is done already. So the answer for this will be fx is the same as 5 bracket x plus 2 squared and then minus 5 at the end. Okay, so that's basically that. 4 marks already. Okay, so please make sure to sketch your graph out and find the respective numbers. Part B. Sketch the graph. Okay, I think we are pretty much done it here, so this is the same as part B. Okay, but of course, like in the exam, please also draw it separately. Part C, solve the inequality for fx smaller than 40. So fx smaller than 40, right? I think there's a lot of ways to do it. So maybe we'll just equate this smaller than 40, and then 4 markers as well. So 5 x plus 1, x minus x plus 3, and as small equals to 40. Divide both sides by 5 first. So we got 40 divided by 5, I think that's 8. So x squared plus 4x plus 3. And then 8's in here. So x squared plus 4x minus 5. Okay, so we need to factorize this as well. So x, I want a positive 4. So I want a plus 5, -1. Okay. So the roots will be -5 and 1 in here. So therefore, number line 1, -5. It's a happy face graph. And I want a part that's like small and 0. So it will be the 1 in the middle. So x greater or equals to -5, small equals to 1. Right, so I think that's basically 4 marks. Pretty easy for this one. Part D, function g is defined by L and x. Write that expression of f of gx. So f of gx. So f of gx would be 5 ln x plus 1, and then ln x plus 3. Okay. Oh, sorry, this is like solve this smaller than 40. So we want to solve I think we got it already, right? Okay, so hopefully recognize that this one and this one are practically the same. So we don't need to solve this again. So, but one thing that I remind you is x is being replaced as ln x. So what you do is we will just do one thing. We just take the answer in here. So x, right? So it becomes ln x between -5 and 1 here. Okay? And how to get rid of the ln is we'll raise every single thing that we see here by e. So the middle becomes x, e -5, and smaller than e at the end. Okay? So I think that's basically it. Okay, so part 2 done. Part E, write down a domain of g of f. So g of f, right? So g of fx. So g of fx would be basically ln and then 5 times x plus 1 and then x plus 3. One thing to remind you is for domain for Ln graph, remember this, the thing must be greater than 0. So we're solving for this. Okay, so divide both sides by 5, you have basically this is gone, right? Because no more. So x plus 1, x plus 3. So x will be -1, -3. So -1, -3. And the graph should look like this. And I want a part that's like bigger than 0. So it's this part and this part. So x smaller than -3, x greater than -1. Okay. Oh, actually we got this graph already. So basically you don't really need to draw it again. Okay, so we use 3 minutes for a AT marker. Okay, so 3 or 4 minutes. So this is an SL questions. I think it's pretty easy. Okay. Okay, plane. Okay, so let's see. So this kind of ugly now. So plane 1 has the equation of this. Plane 2 has the equation of that one. The acute angle is theta. Show that theta is 60. Remember, whenever you find a plane angle, it's always dot product of their normal. So it's like 1, 2, 1 dot 1, -1, -2. This should equals to the modulus of this one. So 1 squared, 2 squared, 1 squared times 1 squared, 1 squared, 2 squared. Okay, so cosine theta. One thing to remind you is the negative you can just ignore it because like when it's squared, the negative is gone. So therefore, I just copy the number here. So left hand side will be 1 minus 2 minus 2. The right hand side, there's like 1 plus 1, which is 2, 2 plus 2, which is like 4, right? So there's like root 4. This is also root 4. Combined together becomes 4. So therefore, this is like minus 2 minus 2. So I think that's like how many? So minus 2, 4. 4 plus -4 plus 1, that's like 3, right? Okay, so let's see. Why is my answer negative? So let's see. 1, 2, 1, 1, -1, -2. And then I'm just going to make sure that I didn't. Oh, sorry, I think I expand wrong number. This is not 4, my bad. Okay. The right hand side here is not 4. Sorry, careless mistakes. It's okay. They give you a show that, so I know that I'm wrong just now. So this should be 6. There's like 1, 1, and it's 4, right? So it should be 6. So root 6 will be 6. So sorry, I'm like trying my best to go through as fast as possible. So therefore, it might be kind of chaotic. 60. So here, cosine theta would be -1/2. So cosine what gives you 1/2 first? So cosine, I think that's like 60 gives you 1/2, right? But since we're in the negative side, then this should be 120 because ASTC 60, right? So 60, but our answer should be negative, so we know that it should be in here 120, and this is 60. But this is the obtuse angle, so this is obtuse angle. But the question told you that it's the acute angle. So remember a plane, right? So plane 1, plane 2. If this is 120, then this here will be 60. Okay, this is like plane 1, plane 2. Okay, so therefore all you need to do, as long as you got 120 and then tell them that the acute theta would be 180 minus 120, so this would be 60. So that's why this is a 6 marker, because like you need to have some, you need to give them some logic at the end. Third plane, perpendicular to both plane 1 and plane 2. The unique point of intersection of all 3 planes is this one. Find the equation of plane 3. Remember, for a plane equation, you need 2 things. You need a point, and you need a vector normal as well. Okay, so what you need to do in here is if we've got a point already. The point is done. It's in here already. We need the normal. Okay, so since they told you that plane 3 is perpendicular to plane 1 and plane 2. Meaning that if this is the normal 1, normal 2, plane 3 will poking into the paper. So the normal of plane 3 could be found by using the cross product of these two. Okay, so 1, 2, 1 cross 1, -1, -2. Okay, so you need to cross this out. So let's do the I first. So this is like -4 plus 1i minus the j. Cross this out, which is -2 minus 1j plus the last one will be the k minus 1 minus 2k. So this is like negative 3i, and then this is plus 3j, sorry, minus 3k. Okay, so at the end, you just use r dot n equals to a dot n in your formal booklet. Normal would be negative 3, 3, negative 3. A would be the point, which is 5, negative 5, and 5. Normal, negative 3, 3, negative 3. So dot it out, it becomes negative 3x, 3y, negative 3z, negative 15, negative 15, and negative 15, I think. Okay, so of course you can cancel at the end, but I'm just taking a safe route here. So minus 45. Okay, divide everything by 3, then we have negative x, y, z, negative 15. Okay, just in case. So this is also a part that we'll check later. So therefore, we spare a lot of time from question 10 is for us to check part B later. So this is plane 3. Okay, so that's basically it. Okay, so next one. Each of plane 1 and plane 2 contains a mirror. Okay. I really like directly to the plane and then make a 45 angle. So now become a physics problem, like angle of incidence, something like that. And then we're plane 2, and then plane 2, kind of plane 3. The ray of light then reflected toward the mirror plane 2, which is here, like Q, and meets the plane 2 at point Q. And P and Q contain plane 3. So basically, plane 3, it's a plane that's like looking towards the paper. Okay. Okay, so let's look at the question. Okay, I think this is like not a vector problem at all. It's just a normal trigonometry problem. Okay, so don't be afraid of all of these things on top. It's just a trigonometry problem. Use a compound angle identity, show that sine 75 is this thing. This is like pretty textbook, to be very honest, because like the thing that you know, 75, right, could be written as 30 plus 45. So what we need to do is just write sine 75 is the same as sine 30 plus 45. This is just some of the combination that all of us should have known when you first learn about compound angle. So this is like sine 30 cosine 45, cosine 30 sine 45. Okay, so sine 30, I think that's like root 3 over 2. Cosine 45, root 2 over 2, plus cosine 30, which is never mind, I think cosine, sorry, sine 30 is 1/2, my bad. I almost recall wrongly. And then cosine 30, that's like 1/2. Wait, never mind. Sorry, I think, wait, root 3 over 2, sorry. Root 3 over 2. Sorry, it's kind of late, so therefore, my brain's not really braining now. And then root 2 over 2. Okay. And then I think we just combine everything together. So root 2 over 4 plus root 6 over 4, which is perfectly the answer that they give us. I think this is pretty easy, to be honest. Okay, next one. Find QR. Give an answer in this form. QR, this one. So we look at the triangle here. We got 2 lengths and 2 angles. It's a sine root 100%, but this match with this, and this should match with that. So let's try to find this angle first. So 180 minus 45 minus 60. So what's that? 120 minus 45. Oh, perfectly. It's 75. So we got that already, right? So use sine rule here. So 5 over sine 75 equals to RQ or QR over 45. QR sine 45. So QR is the same as 5 times sine 45 over sine 75. Sine 45, we know that already. So root 2 over 2, right? So root 2 over 2 divided by the ugly thing that we proved just now. So just write back as a differential fraction. So times 4 over root 2 plus root 6. So what you need to do in here is cancel the 2 and 4. 2. 5 times 2 is 10 root 2 over root 2 plus root 6. So what we need to do is write back as a rationalized form because they don't allow any fraction with roots in the denominator. So we'll multiply the top and bottom by root 2 minus root 6. Root 2 minus root 6. So this will be 20 minus 10 root 6. The bottom will be difference of 2 squared. So 2 times 2 is 2 minus 6. Okay, sorry about that. So the bottom minus 4. Okay, and then what we need to do in here, so P and Q are real integers. Okay, so divided by a negative number, I can just flip it. So we have 10 root 6 minus 20 over 4. Okay, so maybe we can divide everything. Wait, P, Q, R, Z. What's R? P, Q, and R, it's an integer. Okay, so maybe we can do something like this. So 10 over 4 minus 5. Okay, I don't really know what's happening here, so it's okay. So 10 divided by 4, that's like 5 over 2. I'll just try my best to write out my best answer. Okay, I'll just try my best to write the best answer that I could think of. Okay, so I think that's okay already. I don't know, like R should be somewhere. Did they forget to write it? I don't know. Maybe there's like something over R that I don't know, because like, or is like printing error? I have no idea. But this will be my best answer. Okay. If I got something wrong, just let me know. Okay. So hopefully okay. But this is like the general logic behind this question. I think this question is also pretty easy, to be honest. It's pretty textbook. This like this one and this one's pretty easy. Okay. So not a hard paper at all up to this point. So the last question. Integration. So let's see. I think this question will be hard, because like, to be honest, like the 11 question beforehand is pretty trivial. By writing cosine as cosine, make 1 cosine, show that this equation. Oh, there's a what I call a reduction formula of cosine. Reduction formula. So this is not in your formula. It's not in your syllabus for IB, but this is actually a well-known properties of a cosine reduction. So what we need to do is we want to reduce the power of n into something like n minus 2, so we can integrate it further. So writing cosine as cosine negative 1 times cosine, so we'll just follow it. So cosine n minus 1 x cosine. So what we need to do is obviously a by-part question. So dv dx, and we'll take cosine, and then for u we'll take cosine n minus 1 dx. So v would be sine, and then your du dx, chain rule, so n minus 1 cosine n minus 2, and then chain rule inside negative sine. Okay, and then what you need to do is use the by-part formula. So first of all, uv, so sine x cosine n minus 1 x minus the integral of v du dx, right? Okay, so it will be let's say here, this one times this one. So first is a negative, so therefore I will just change that plus sine squared x, and then n minus 1 cosine n minus 2 x dx. Okay, so that's like the formula for by part. So afterwards, what we need to do. Okay, so we got n minus 2 already. We want the cosine power of n. So we want cosine only, right? So first of all, to be very honest, let's try to factorize the n plus minus 1 out first. Sine squared, let's change this to a cosine squared. So 1 minus cos squared. To be honest, this question is not hard, but like a lot of things to memorize. I think we have the answer already. So we expand everything, then we have sine x cos n minus 1x plus n minus 1 integrate of cosine. Sorry, this is like n minus 2, not n minus x. Okay, n minus 2 x minus. So basically we just separate 2 integral in here. Doesn't really matter. So this is minus, right? So minus of these 2 multiply. But at the same time we got an n minus 1. So therefore I need an n minus 1 in here as well. So basically just copy the answer. I think that's okay already. So cosine n x dx. Let's double check. N minus 2, n minus 1. Okay, perfect. I think that's it already. So part B, what do we want? hence show that, okay, this is this one, right? Oh, I see. So basically what we need to do is oh, okay, so hopefully recognize that what we've done just now, these and this are the same, right? So we need to move this to the left hand side and then divide both sides by everything that we got here. So we're gonna have this approach because this one is the same as this one, right? So then what we need to do is we'll write the whole equation here. Okay, I'll just copy and paste here, to be honest. Kind of lazy. So let me copy here. So copy, paste. Okay, so this is the equation, and don't forget that this is the same as cosine nx, right? This and this are like terms, so you can combine them together by moving this to the left. So this is like a 1, right? 1 plus n minus 1. So that's like n. So therefore, you got this equals to the right hand side. And then we'll divide both sides by n, and that should be the end of this question. Okay, part C. Hence, find power 4. Okay. Oh, sorry, this is m as 2. Okay, power 4, right? How many marks for the power 4? 4 marks, and write it back as this 4. Okay, so power 4. So we just plug in n equals to 4. So 1 over 4 sine x cosine cube x. 4, right? So 3 over 4 of cosine square x dx. So what we need to do in here you can use the reduction formula again. So let's say if you want to, what you can do is put 2 into here again, and then do the same stuff. Actually, I'll just do that because I think it's easier. So put 2 in the inside as well. To be honest, like, because if you use the double angle formula approach, this might be I'm kind of lazy, so I'm like trying to avoid that. So put 2 in here. So we'll have 1 over 2 sine x cosine. So put 2, right? So this is power of 1, and then plus 2. So 2 minus 1 over 2. So 1 over 2, and then integrate of cosine 0. Cosine 0 is 1, right? So basically x. Don't forget plus c at the end. So 1 over 4 sine x cosine cube x plus 3 over 8 sine x cosine x plus 1, also 3 over 8 as well, x plus c. So sine cosine cube, sine cosine x, and then a number. I think that's basically it. Cosine cube, and they're of the rational number, right? Okay, so I think that's basically it. Okay, so D. The region is rotated. Okay, so the graph here, it's cosine squared, and then one find following the revolution around the x-axis. Okay, revolution around the x-axis, right? So y squared dx around the x-axis. So yeah, so we're going to square this because we want y squared. So cosine power 4. Oh, that's why they gave us that. So pi integrate negative power 2 to power 2, okay, of cosine power 4. So we don't need to integrate that already. We have this already, right? So we just plug in. Okay, so this is the part that you requires a lot of like mental math. But to be honest, it's fine. I'm thinking of another approach. Is since I know this is an even function, I can actually divide this by 2, so 1 and 2, and then we can find maybe one of the area and times that by 2. I think that's also okay, but I don't think that's a problem for this one. So let's put power 2 inside. Okay, so sine 90, right? So all of them are 90 anyway. So in the sine 90, it's 1. cosine 90, bye-bye, it's 0. And then 3 over 8, sine 90 is 1, cosine 90, so 0. So basically all the sine cosine 0 in here. Plus 3 over 8 pi over 2, so 3 pi, I think, over 16, right? Over 16. Minus, so put negative inside. So actually, at the end, this is that. So basically just the number at the end as well. So minus 3 over 8, so 3 pi over 8. 3 over 16. So at the end, if we add just this and this up, it will be 3 pi over 8 at the end. Okay, so 4 marks. But I think this is pretty easy. So E. Find a Maclaurin series of Fn up to x power of n. What was it? Like, okay, in here, right? Okay, so let's try to find out. So up to x power of 2. Okay, so Fnx is cosine nx. So differentiate this once. So let's just put 0 first. Let's try to put 0 first. Put 0, it's like 1 part of n, right? So which is 1. And then differentiate this once. Will be n cosine x. N minus 1. Okay, so maybe I'll write it like this. N minus 1 x, and then chain rule inside, negative sign. Put 0, I think it's dead. 0. Double derivative. So what you do is differentiate this again. So this 2, just leave it negative n. Chain rule inside. So differentiate the cosine first. It will be n minus 1 cosine n minus 2 x. Chain rule inside. Don't forget to copy the sign. Plus differentiate the sign, which is cosine. And then copy the front, which is cosine n minus 1x. Okay, put 0. The whole front will be gone, so just negative n times this one. So 0, 0, 1 times 1, so we're just 1 at the end. Okay, and I think that's basically it. So at the end, it will be 1 plus, so 0, right? And then so minus n x squared over 2. Okay, and hence and otherwise find this. Bro, this is like kind of stupid. So limits as n tends to 0. Fn, right? So 1 minus n squared 2 over 2, like this. And then minus 1. Sorry, it's lagging a little bit. So minus 1 over x squared. Okay, so cancel 1 first. So we got limits n tends to 0, and this becomes just minus n x squared over 2 over x squared. So minus n over 2. Okay, done already. So I think that's basically the whole problem. I used like around 1 hour for the whole paper. So of course I'm a teacher, right? But as a student, I think 1.5 hours should be more than enough. But this is the question that I'm not sure, to be very honest. Like kind of like annoying. But in general, I think this paper is a definitely like 8 out of 10 in terms of difficulty. Okay, because like this one's kind of annoying. And this is like kind of not that usual. This actually for some student might be hard. And then homogeneous is also very hard for a lot of AAHL as well. This is easy. This is easy, just like they might give you something that's like scary. And then the last one is a reduction formula. I think the last question is it's a bit hard for part A and B and C. Okay, but I think generally the paper is like 8 out of 10 in terms of difficulties. Okay, so thank you very much. This will be my suggested answer. So just treat this answer as some of the idea might not be fully correct. Okay, so thank you very much for watching. See you again. Bye bye.